So we've got some weird graph of g of x, and we want to sketch and label its image after a vertical compression of 1/3 by a factor of 1/3, and then a translation of 2 units up. So again, we're going to take our points. In this case, we've got 4 key points, so we're going to start by labeling all 4 of those key points. We've got -5, 3, -2, -3, 1, 0, and 4, 6. And we're always, whenever we got stretches and compressions, along with translations, we'll always do them separately. I don't know if you want to label the first set of arrows as stretches and the second set of arrows as translations right now, just to help you remember that. But all of our stretches and compressions and reflections go in that first one, because that's where you're multiplying your coordinates by something. And then all of our translations happen second, because that's when you're adding and subtracting things. So if we do that, we write above the arrow what we're going to do. What are we multiplying by? Vertical compression by a factor of 1/3. That means we're multiplying our y values by 1/3. Then a translation of 2 units up. Then we'll be doing 2 up after that. So we're multiplying our y coordinates by 1/3. We do that first. -5, 1, -2, -1, 1, 0, 4, 2. Secondly, we move it 2 up. -5, 3, -2, +1, 1, 2, and 4, 4. We can go and plot these points on our new graph. So -5, 3, -2, 1, 1, 2, and 4, 4. Connect the dots. And we have our new graph. What is the equation of that new graph?
It should be -5, 1.
Oh, I think we're good. Yeah. No, good. So there's our final graph. If we wanted to write the equation of that graph, how do we show y by 1/3? That would be outside of the function multiplied. How do we show 2 up? That would be outside of the function plus 2. Now, before I give you questions on this, I do want to do the example that is given to you in the textbook. So I'm going to just go back to the one on the side. You don't have to take any notes for this one. We're going to do the same thing. Everything's very similar. The setup is the same. Labeling of the points is going to be the same. But I want to show you something with the equation that happens with this one. So we've got -4, 3, -2, 0, -2, 2, 5, 4, 2, and in this one, there's a horizontal compression by a factor of 1/2. So whenever compression by a factor of, you are actually multiplying x by 1/2. Then a translation of 3 to the left after that. So our original points, what's going to happen? X by half, negative 2 comma 3, 0 comma negative 2, 1 comma 5, and 2 comma 2. And then 3 to the left, negative 5 comma 3, negative 3, negative 2, negative 2 comma 5, and 0 comma 2. So currently in this question, nothing is different. We're just dealing with x instead of y. This is really just a review of what we've done. We can now plot those points. So negative 5 comma 3, negative 3 comma negative 2, negative 2 comma 5, and 0 comma 2. So it's been compressed horizontally and then moved 3 to the left. What I do want to point out with this question is the following. When I go to write this equation, yes? Yes. Thank you. See, easy mental math mistakes. So easy to do. Negative 1 comma 2. There we go. So when we write this equation, we have x by a half. Whoa. Y equals x by half. Is that inside the function or outside the function? Inside. So we're going to have f, and is it going to be a half in there? It's going to be a 2. And then the 3 to the left, plus 3 or minus 3? Minus 3. So plus 3, thank you. Okay. Now I'm going to write this in two different ways. Oops. Oh man, I'm having troubles here writing the second way. And I want you to notice a small difference. One, I have 2x plus 3. The other one, I have 2x plus 3. But the one on the right, I have an extra set of brackets. If I actually distributed this one, this would be 2x plus 6. You agree that this one here is the same as two x plus 6, okay? And 2x plus 3 and 2x plus 6 are different. So because they're different, only one of these equations is right and one of them is wrong. So I want your gut to tell you, I want you to think about which one you feel is right and which one you feel is wrong, and then we'll talk about that and go from there. You don't have to say which one you think is right and which one you think is wrong. Now, if I'm trying to read your gut reactions, and I would say some of you would choose this one because your gut says that's simple, straightforward, no extra brackets. I like that. That's what my gut says. I'm going to go with that one. Some of you would choose this one because you've said to yourself, well, so far everything inside the brackets has been against what my gut says. So now my gut says to go against my gut, and I'm going to choose the second one. Whew. In reality, this is the one that's right. We will write it like this. We won't write it like this. This one is not right. And so at the bottom of this page, there's some space before the bottom of the page. We're going to add the following special note. And this special note happens with horizontal stretches and horizontal translations. So when you have a horizontal stretch or compression or reflection and a horizontal translation, comma, you must write it in factored form. So that's what we have in that green box. That the 2 is factored out of that x plus 3. That's what I mean by factored form. When it's written that way, then we know it's 3 to the left and a horizontal compression by a factor of 1/2. So that's why this time I did both examples. I did the one off to the side and I did this one. The questions you can do right now to start are 4, 5, and 6.